In this video we'll be looking at special angles, so 0, 30, 60, 45, 90, 180, 270, and 360, and special triangles that come from these angles right here, 30, 60, 45, and 90. And important vocabulary here, quadrantal angles are those that are integral multiples of 90, so 0, 180, 270, 360. And if you draw a coordinate plane, they're just at the four corners. So here, 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 and here is where those would all line up, so that's why they are special. And the easiest way to evaluate the trig function values of these angles is by using x, y, and r. So this vocabulary, quadrantal, you need to get that down and understand what it means. It means it's at one of the four corners, here, 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 or here. Alright, so in the following two examples, draw the terminal side of the angle in standard position containing point P with a radius of 1. This is going to be important, so that's like the unit circle that we briefly discussed. Label the x, y values of this point, then determine the values of sine, cosine, and tangent. So 90 degrees would be right here, so we'll use red and try to make that thick there so that we can see it, and the point would be right there, so the ordered pair would be 0, 1, and that means that x is equal to 0, y is equal to 1, and r is equal to 1. This radius, they told us that distance is 1. So the y coordinate's 1, x coordinate's 0 there. So we just use our x, y, and r definitions. So cosine of 90 degrees is equal to x over r, so 0 over 1, or 0, so cosine 90 is 0. Sine of 90 degrees is y over r, so 1 over 1, or just 1. And tangent of 90 degrees is equal to y over x, so 1 divided by 0. Can't divide by 0, so it's undefined. Tangent of 90 degrees is undefined. Alright, let's look at example 2. Okay, example 2. 180 degrees. So I've gone ahead and drawn that 180 degrees in standard position, and we'll label the point. It would be negative 1 comma 0. So x is negative 1, y is 0, and r is 1 because we're using a radius of 1 here, that distance. So identify the three major trig functions. So cosine of 180 degrees is equal to x over r. So for us that's negative 1 over 1, which is negative 1. So cosine 180, negative 1. Sine 180 is equal to y over r. So for us, that would be 0 over 1, or 0. And lastly, tangent of 180 degrees is equal to y over x. And again, we've already discussed in previous lessons how to define these in terms of x, y, and r. So the assumption is you've already gone through those lessons. So y over x, for us, that would be 0 divided by negative 1, so that would be 0. So sine 180, 0, tan 180, 0, cosine 180, negative 1. Alright, let's look at the next section. Alright, in this section it says the angles 30 and 60 are special angles, both coming from a 30, 60, 90 triangle. Recall from geometry the following relationship between the sides of this special triangle, and we really need to have this memorized. So I'm going to draw two of them. Visually, this is usually students like this better, so we'll draw that one, and then over here we're going to draw the same angles but just in a different position, and I'll discuss why in just a moment. So this would be our 90 degree angle here, and then 30 here, and 60 here, and over here we have our 90 here. This would be our 30, and this would be our 60 degree angle. And to draw it correctly, obviously the 30 degree angle points at the shortest side, 60 degree side angle points at the medium side, and of course hypotenuse is the longest side. And same thing over here, 60 points at the second biggest, 30 at the smallest, hypotenuse points, angle points at the, or the 90 degree angle points at the hypotenuse, which is the longest. Okay, so we need to label these sides, and these were sides that you did work with in geometry, so it's 1, 2, and square root of 3 are the sides. So same thing over here, 60 degrees goes with square root of 3, 30 degrees goes with 1, and the hypotenuse is 2. And if you work those out, you would see that those ratios worked out. So if you do the Pythagorean theorem, which is c squared equals a squared plus b squared, you get 4 equals 3. The square root of 3 squared is 3, plus 1 squared is 1, so 3 plus 1, 4. So 4 equals 4. So that works out. So you really want to memorize these triangles. The reason why I drew 2 of them is this is a triangle with a standard position 30-degree angle here at the what would be the vertex at the origin there at that corner, and then this one has the 60-degree, and visually it's just usually easier for students to work with. So that's why I drew 2 of them. They're the same, technically the same triangle, just rotated differently. All right, example 3, having previously memorized the 6 trig functions in terms of opposite, adjacent, hypotenuse, these functions are easily determined for 30 degrees. So I'm going to pause here, copy this triangle down, and then we'll label it appropriately. All right, so here's this triangle copied down. So we're working with 30 degrees, so here's our 30-degree angle. So from the 30-degree angle, this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse. So using those definitions, we'll start with sine, it doesn't matter. Sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. So for us, that would be 1 over 2, 1/2. And instead of theta here, we're using 30 degrees. Let me fix that. So sine of 30 degrees is 1/2. Cosine of 30 degrees is equal to adjacent over hypotenuse, abbreviating all of that. Adjacent over hypotenuse. So that would be square root of 3 over 2. And tan theta, tan of 30 degrees is equal to opposite over adjacent. So for our case, opposite is 1, adjacent is square root of 3. And then we should fix that, and we've discussed this pattern before. It would be square root of 3 over 3. And let's see, we want all 6 here. So the reciprocal of sine theta, we'll use another color, is cosecant theta. So in this case, cosecant 30 degrees. So that would be 2 over 1, or just 2. It's just the reciprocal of that. And then reciprocal of cosine is secant, so secant of 30 degrees would be 2 over square root of 3. Fix that, make it 2 square root of 3 over 3. And we're rationalizing the denominator here. We've done that in previous lessons, so go back and check those out if that's giving you trouble. And then the reciprocal of tan is cotangent, so cotangent of 30 degrees would be, just flip that over, square root of 3 over 1, which will just make square root of 3. All right, so that's it for example 3. All right, now for example 4. Similarly, the 6 trig functions of 60 degrees are determined. So we need to, I just kept the same triangle, so now the hypotenuse stays the hypotenuse, but we need to switch these two. This is now the opposite side from 60 degrees, so we'll label that opposite side. And this side is now the adjacent side to 60 degrees based on this particular triangle. So now we can start labeling all of the trig functions. So sine of 60 is opposite over hypotenuse. So in our case here, that would be square root of 3 over 2. And cosine 60 is adjacent over hypotenuse. So that would be 1 over 2, 1/2. And then tangent 60 is equal to opposite over adjacent, abbreviating all of these. So that would be square root of 3 over 1, or just square root of 3. We'll leave that alone. And now the others. So the reciprocal of sine is cosecant. So cosecant 60 is 2 over square root of 3, which we will rationalize that denominator, make it 2 square root of 3 over 3. And reciprocal of cosine is secant, so secant of 60 degrees is this reciprocal, so 2 over 1, or just 2. And then lastly, cotangent of 60 degrees is the reciprocal of tangent, so it would be 1 over square root of 3, and then we'll rationalize that and make it square root of 3 over 3. And if you go back and look at these previous examples, you'll notice the same pattern showing up. They're just in different places, but you see the same numbers: 1/2, square root of 3 over 2, square root of 3, 2 square root of 3 over 3. You see those showing up. But so, in other words, look at it this way: sine of 60 is square root of 3 over 2. So come up here, and cosine of 30 is square root of 3 over 2. That's what I'm saying. You see the same patterns. Sine of 30 is 1/2, but down here, cosine of 60 is 1/2. Again, you see these same square root of 3 over 2, 1/2. You see those repeating. So make sure you see those patterns there. All right, let's look at example 5 next. All right, this next section here, I've gone ahead and drawn the triangle here and then proven that it works out using Pythagorean theorem over here. So you may want to pause the video and write it down. But this is the special 45, 45, 90 triangle, and the sides that we use are 1, 1, and square root of 2. And using the Pythagorean theorem, we've proven here that that is correct, and that would be the correct ratio for those sides. All right, let's look at example 5. Having previously memorized the 6 trig functions in terms of opposite, adjacent, and hypotenuse, these functions are easily determined for 45 degrees. So we'll use this 45. It wouldn't matter if we use this one as far as that goes. So from this 45-degree angle, this would be the opposite side, this would be the adjacent side, and this is the hypotenuse. So now we can label all 6 trig functions. So cosine of 45 degrees is equal to adjacent over hypotenuse. So for us, that's 1 over square root of 2. Rationalize that denominator, square root of 2 over 2. Sine 45 is going to be exactly the same because the opposite and adjacent sides are the same here. These angles are the same, therefore their sides are the same that they face. So sine of 45 degrees is opposite over hypotenuse. That's still 1 over square root of 2 because the opposite and adjacent sides are the same. And rationalize that denominator, square root of 2 over 2. And tangent 45 degrees, tangent of 45 degrees is opposite over adjacent. So that would be 1 over 1 or just 1. So tan 45 is 1. Now the reciprocals. So reciprocal of cosine is secant 45 degrees is, just take this reciprocal, square root of 2 over 1 or just square root of 2. And what do you think that means about cosecant 45 degrees? Well, hopefully you know that it's also going to be square root of 2 because it's the reciprocal of sine, and since these were the same before, that means these are the same. And then that also means that cotangent 45 degrees is going to be pretty easy in this case. The reciprocal of 1 over 1 is still 1 over 1, so it's just 1 as well. So there are the 6 for 45 degrees. All right, example 6. Evaluate the sine, cosine, and tangent of 120 degrees. So what we're going to do here is we'll sketch this out. So we have a coordinate plane here, 120 degrees. We start here at our initial side. So we're in standard position. That would be 90, 180 to here. So 120 is here. So this angle right here is 120 degrees. And what we're going to use is a new vocabulary word of a reference angle. So this reference angle here would be 60 degrees. If it's 120 to here and 180 all the way down, then that difference right there would be 60 degrees. That also means this has to be 30 and this is a 90-degree angle. So we have our special 30, 60, 90 triangle. So the reference angle in this case is 60 degrees. Whenever your reference angle is 30, 45, or 60 degrees, you can use those special triangles that we've developed earlier in this lesson to find the trig functions of the value that you need. So again, the vocabulary here is reference angle. Reference angle is the angle from your terminal side, so in this case this is our terminal side, to the closest x-axis. So as a few more examples here, if I have a terminal side right here, this is my reference angle. If I have a terminal side down here, this is my reference angle. It's the closest x-axis, not all the way to here. It needs to be less than 90 degrees. If I have a terminal side down here, down here like this, then that would be my reference angle. So if your reference angle is 30, 45, or 60, you're going to be using those special triangles because it makes it faster. You know those values. You should know those values already, and you can make this work a little faster. So our ratios were the 30-degree side with our 30, 60, 90 triangle was 1. Our hypotenuse here in this case would be there, and that's 2, and our 60-degree side was square root of 3. So that is the proper way to label that. We did that before. That's our 30, 60, 90 triangle there. Okay, now let's identify the trig value. So sine of 120 degrees is opposite over hypotenuse. So for us, the opposite side of our 60 degree is square root of 3, and the hypotenuse is 2. So sine of 120, square root of 3 over 2. Cosine of 120 degrees is adjacent over hypotenuse, and in our special triangle, from the 60-degree angle, the adjacent side is 1, this one, and the hypotenuse is 2, and there's one change we need to make here. This, because of it's in quadrant 2, the x-coordinate must be negative, so I need to make that negative. So cosine of 120 is negative 1/2. If you said positive 1/2, that would be wrong. Okay, tangent of 120 degrees is opposite over adjacent. So in our case, our opposite side from this angle is square root of 3, and the adjacent side is negative 1. So altogether, that would be negative square root of 3 over 1, negative 1, or square root of 3 over negative 1, so make it negative square root of 3. All right, so sine of 120, square root of 3 over 2. Cosine of 120, negative 1/2. Tangent of 120, negative square root of 3. And we didn't need to know anything about 120 because we knew 60. 60 was our reference angle. We were able to apply our special triangle. So again, key concept here is if your reference angle is 30, 45, or 60 degrees, you should use your special triangles to help you identify the trig values. All right, that's it for this lesson. That's it for this video.